Black holes are among the most fascinating objects in the universe. These enigmatic cosmic entities captivate astronomers and science enthusiasts alike, with their immense gravity and bizarre properties. But how do these cosmic powerhouses come into existence? In this video, we will explore the various ways that black holes can form in space, from the collapse of massive stars to the merging of smaller ones. Join us as we delve into the incredible processes that give rise to these mysterious objects. One way that black holes can form is through the gravitational collapse of a massive gas cloud. This process is similar to the formation of a star, except that the end result is much more extreme. When a cloud of gas and dust is massive enough, gravity causes it to collapse in on itself. As the cloud collapses, the particles within it collide more frequently, increasing in temperature and pressure. If the core of the cloud reaches a temperature of several million kelvins and a pressure of several hundred billion times Earth's atmospheric pressure, a new star is born. However, if the core continues to collapse beyond this point, it will eventually become so dense that not even light can escape its gravitational pull, resulting in a black hole. The exact mass required to form a black hole varies depending on the nature of the collapsing cloud. For example, if the cloud contains a significant amount of iron, which has a particularly strong gravitational pull, less mass will be required to form a black hole. Conversely, if the cloud contains less massive elements, more mass will be needed. Theoretical calculations suggest that a cloud with a mass of about 200,000 to 400,000 solar masses could collapse and form a supermassive black hole. While this may seem like an enormous amount of mass, it is not unheard of in the universe. In fact, many galaxies contain supermassive black holes at their centers, with masses millions or even billions of times that of our Sun. Another way that black holes can form is through the merger of smaller black holes. As black holes move through space, they can interact with each other's gravitational pull, causing them to merge into one larger black hole. This process can occur multiple times, with smaller black holes merging to form intermediate-sized ones, which then merge to form larger ones. Over time, this can lead to the formation of supermassive black holes. Mergers of black holes can also occur when two neutron stars orbit each other closely and eventually merge. Neutron stars are incredibly dense objects that form when a massive star collapses at the end of its life. When two neutron stars merge, the resulting object can be extremely massive and may collapse into a black hole. Scientists have detected gravitational waves produced by the merger of two black holes. These observations provide strong evidence for the existence of black holes and have allowed astronomers to study their properties in greater detail. By analyzing the gravitational waves emitted during the merger of two black holes, scientists can learn about the masses of the individual black holes as well as the properties of the space-time around them. Additionally, mergers of black holes can play a significant role in the evolution of galaxies. Supermassive black holes in particular have been found to have a profound impact on the structure and dynamics of the galaxies they inhabit. The material that falls into a supermassive black hole forms an accretion disk, which emits large amounts of energy and can regulate the star formation in the galaxy. Mergers of smaller black holes can also contribute to the growth of supermassive black holes, providing the additional mass needed to increase their size. Overall, mergers of black holes are an important aspect of their formation and evolution, and studying them can provide valuable insights into the properties of these enigmatic objects and their role in the universe. It's worth noting that black holes aren't just cosmic vacuum cleaners that go around consuming everything in their path. While they do have a powerful gravitational pull, their effect on nearby objects depends on their mass and distance. Black holes of intermediate mass typically have a radius of only a few kilometers, while supermassive black holes can be millions or even billions of kilometers in diameter. This means that even though they have a strong gravitational pull, they don't necessarily affect objects that are far away from them. In fact, most of the mass of a black hole is contained in the region just outside of its event horizon, meaning that the majority of its gravitational pull is focused in this area. As a result, objects that are far enough away from a black hole's event horizon can orbit it in a stable fashion without being pulled in by its gravity. For example, the material in an accretion disk around a supermassive black hole often forms a flat, rotating structure. Because the black hole's gravity is balanced by the centrifugal force of the rotating material. This balance between gravitational and centrifugal forces allows the material in the accretion disk to orbit the black hole without falling into it. Therefore, while black holes do have a significant gravitational pull, their effect on nearby objects depends on the specific circumstances, and it's not always as dramatic as one might imagine. In addition to their immense gravity, black holes also exhibit some bizarre properties that make them truly unique objects in the universe. One of the most well-known properties of black holes is their event horizon, which is the boundary around the black hole beyond which nothing can escape. Once something crosses the event horizon, it is pulled into the singularity at the center of the black hole where all matter and energy is destroyed. The event horizon of a black hole is defined as the point of no return, where the gravitational pull is so strong that not even light can escape. This means that once something crosses the event horizon, it is impossible to observe what happens to it. Because no light or other electromagnetic radiation can escape from inside the event horizon, it is invisible to all forms of observation. The boundary of the event horizon is often represented by a spherical surface, but it is important to note that it is not a physical thing that can be seen or touched. It is simply a theoretical boundary that marks the point of no return. Crossing the event horizon of a black hole is a one-way journey. Nothing can travel back across it to the outside world. This is because the gravitational pull becomes infinitely strong at the event horizon and requires an infinite amount of energy to escape. This means that any object that crosses the event horizon will continue to be pulled towards the center of the black hole and cannot escape. Black holes also exhibit some strange behavior due to their intense gravity. One of the most notable of these is the gravitational lensing that occurs around black holes. Gravitational lensing occurs when the gravity of a massive object distorts the light from objects behind it, creating a magnified and distorted image. This happens because gravity warps the fabric of spacetime, and black holes have such a strong gravitational pull that they can cause significant distortion in the spacetime around them. As light passes by a black hole, it is bent and magnified, making objects behind the black hole appear larger and distorted. This phenomenon can be used to study the objects that are hidden behind the black hole, as well as to detect the presence of black holes themselves. Another strange property of black holes is their ability to create time dilation. Time dilation occurs when time passes slower for an observer who is close to a massive object with a strong gravitational field. Black holes have such a strong gravitational pull that time slows down significantly near their event horizon compared to the rest of the universe. This means that an observer who is close to a black hole would experience time passing more slowly than someone who is far away from it. This phenomenon has been observed by satellites that are close to Earth's surface, as well as by astronauts who have traveled to the International Space Station. While the effects are small, they are measurable and confirm that time dilation does occur due to gravity. Finally, black holes are also known for their ability to emit a thermal spectrum of light known as Hawking radiation. This radiation is named after Stephen Hawking, who predicted its existence in 1974. According to Hawking, black holes are not entirely black, and they emit a faint glow due to quantum effects near the event horizon. This radiation has a temperature that is inversely proportional to the mass of the black hole. This means that smaller black holes emit more radiation than larger ones. Hawking radiation is incredibly faint and difficult to detect, but it has been observed in some supermassive black holes. The discovery of Hawking radiation would be a major breakthrough in physics, as it would provide evidence of the theory of general relativity breaking down at the event horizon of a black hole. In conclusion, black holes are fascinating objects that exhibit some of the most extreme properties in the universe. They can form through the gravitational collapse of massive gas clouds or the merger of smaller black holes. Their immense gravity creates a region of spacetime known as the event horizon, which is the boundary beyond which nothing can escape. Black holes also cause gravitational lensing and time dilation and emit a thermal spectrum of light known as Hawking radiation. These bizarre properties make black holes some of the most mysterious objects in the universe. And studying them can provide valuable insights into the fundamental laws of physics and the nature of reality itself. Thank you for joining us on this exploration of the amazing world of black holes. We hope that you have learned something new and that you are as fascinated by these enigmatic objects as we are. If you enjoyed this video, please be sure to subscribe to our channel for more videos on space and the universe. We also encourage you to leave a comment below with your thoughts on black holes or any other topics that you would like to see us cover in future videos. Your feedback is very important to us, and we value your participation in our community. Once again, thank you for watching, and we look forward to seeing you in our next video.